Hello everyone, this is the second lecture in our Python series. Last time we talked about the syntax and semantics of the Python language. We talked a little bit about scalar objects and simple operations, and we concluded with expressions, variables and values in this exciting programming language. So today we will talk about string object type, branching and conditionals to direct the flow of the control towards certain direction in our Python script. We will talk about the Python's management of the code blocks. So I will show you how indentation is utilized to denote certain lines of code as a unity, as a code block. And lastly, we will conclude this lecture by talking about iteration and loops. So in Python, we typically use quotation marks, either single or double quotation marks, to denote strings, and we need to define the strings at this point. Strings are literally a collection of letters, special characters, spaces and digits. So basically this set of characters is treated in a special way in programming languages, and they are typically called as strings. So there are multiple operations we can perform on string operands. For example, we can concatenate two string operands to form a larger string. Here we have an example. For example, here name is assigned to value of Anna, and whenever we write this line here, we run this line in the interpreter, greet equals hi plus name, we get the result hello there Anna, because here hi has the value hello there, it's a string, and we use plus sign to perform the concatenation, because here we have two strings as the operands. So this is going to be concatenation definitely, and the name holds the value of Anna, so we will have hello there Anna. We can also utilize other things, like we can define strings locally instead of first assigning them a variable name, such as down here, like name, greet, hi. We can also define them in situ like this using quotation marks. And some of the mathematical notation, as you have already noticed, is used on string operands. Here we used plus sign. We can also use multiplication sign, and in this context, if we have a string operands here, string parameters, the significance of this multiplicative sign becomes the repetition operation. Basically, if we execute this line, what happens is that the value which is held by the name variable here will be repeated 3 times. So we will have hi space Anna, 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 because name holds the value of Anna, and we ask interpreter to repeat this name 3 times. If we make this 5, it is going to be repeated 5 times. So just like in other language, Python also offers us special functions to put some values on the console, as well as to take some input from the user, such as from a keyboard. So to be able to print something on the console as the output of a program, we use print function. Here is a very simple example of it. For example, here the x variable is assigned to the value of 1, and whenever we write print x, we will get 1 as the answer. We can quickly try this. So x equals 1, and we write print x here. What happens is that, as you can see, the interpreter outputs 1 as the result of this operation. So here what we see is that x, this number, this integer number here, is converted to a string. So x str here is a holder for a string. It is not integer anymore. So whenever we execute this print line here, what happens is that first this string, which is given in this double quotation marks, will be printed, and then after that the values that are placed at the end of the string with the comma separators will be printed in order. So we can also see this in action. We can just copy this, we can pass it here. Oops, okay, there is an issue with the past. So we can just make a simple demonstration, then I will fix this issue later. Let's say value is, then we put comma here, and then whatever we want, for example x in this case. So as you can see, x is replaced by its value, which is 1 as we defined here, and these values provided within parentheses, they are concatenated to form the main string which will be printed on the console, as you can see here. So let's move. In the previous slide we have seen how to output to a console, and we also need a method to take values from the user using either keyboard or another input device. So a simple way of doing this is using input function as given here. So what happens is that we just write a prompt here. This is shown to the user, and the system, the interpreter, waits for user interaction. Whenever user types something and presses enter button, then that value will be read and it will be assigned as the value of the variable which we provide to this function. And here what happens is that, okay, the user is prompted with this, type anything, and that user enters some number or character, whatever, and then that is transferred to the text variable here, and we ask interpreter to print that text which is provided by the user 5 times to the console. So let's try something similar. So again, same thing, text input. So we say type something here, and then whenever we do this, as you can see, we see the prompt here asking for our interaction with the keyboard. So let's say I will write y u like 8, something totally random. Whenever I click, we get back to the interpreter interactions line here. So now we can check what value is assigned to text variable here. As you can see, it is assigned with text that we entered into the console. So whenever we write print text multiplication 5, that is repeated 5 times, as you can see. Also we can like play with this example a little bit just to show you how useful mathematical operations can be when we are dealing with strings. As you can see, we can do some inline addition of space using this single quotation marks and a space between them, and using summation sign. Then we can ask interpreter to repeat this combined text 5 times. As you can see, yu8 space yu8, so you get the idea. It is quite useful. One important thing is that this input function it always provides you with a string, not a number. So be careful about this. If you are expecting a number to be entered, then you have to do the typecasting explicitly. So you ask user to enter a number, then this function returns you a string, then you explicitly typecast that string into a number. In this case it is integer. Then whenever you perform this operation, what happens is that now you will have a number. So that number will be multiplied mathematically by 5, and the Python interpreter will output that result to the console. So let's move into mathematical operators, actually like logical operators, Boolean mathematics in a sense. So we have various Boolean operators here. For example, we have greater than sign, which is denoted by this, greater or equal to, less than or equal to, and not equal to. So what happens is that whenever interpreter encounters such kind of operation, it will evaluate this expression, and the interpreter will return a value, a boolean value, either true or false, depending on the conditions satisfaction here. So for example, so here we can use similar things, similar operations on booleans as well, boolean variables. So whenever we want to invert, we want to obtain the inverse of a boolean variable, so we can use not. In some languages this is like an either like a tilde sign or an exclamation mark, depending on the language, but Python provides us with this nice English-like words, so we can directly use that one. We can also use AND operation or operation. For example, in C language this is denoted by ampersand sign, and in C language OR operation is denoted by vertical bars. But again, Python provides us with convenient ways of denoting these operations. We can just write AND and OR, just as we do in English. So here we have a comparison example. We have two variables with values 15 and 8, and we ask interpreter to calculate the result of this logical operation. We want to check whether sleep time is greater than pset time. So in this case the sleep time is 8 and pset time is 15, so 8 greater than 15 is false, apparently. And this will be execution of this statement will return a value of false. So whenever interpreter comes to this print function, it will print false as the value. So in the following lines we have again two more variables, two more boolean variables specifically. One has the value of true, another one has the value of false, and we ask interpreter to check whether this logical operation, drink and derivative, is either true or false, and we assign that value to the variable both, which is of course boolean type in this case. And drink is false here, and derive is true, so false and true, as you know, evaluates to false, so both has the value of false, and this print line will output false as the result. So while we are writing programming, we often use branching mechanisms, and to be able to take the correct branch we need to perform some comparisons, and depending on the results of those comparisons, such as greater, greater than, or equal to, or not equal to, depends on what kind of conditions you are checking, we take different actions. We can ask program to like skip a field line, or we can ask program to like completely change its execution from a certain route and switch to another branch. And if that is a dead end, then we can go to another branch till we are satisfied with the results, till we perform all of the required actions within the script. So to perform this kind of control flow in Python language, we have a couple of ways, and the most common is like if statements, which also exist in almost all of the programming languages. So this is how we utilize this useful statement. We write if, then we put the condition, then at the end of condition we use a colon here. One thing to note is that Python uses indentation, as you can see here, to denote code blocks. So whenever you write if and you put this colon sign, the next lines has to have some indentation, inner indentation, till we of course have another condition, just like here, or we reach the final branch, which is the default case here, like else. So we can do either if else statement, or if we have more than one condition to be checked, so we can also use if, elif and else, and we can repeat elif statements as many times as we wish. Here elif stands for else if, so it is like a shorter version of those two words, and it is quite like convenient to use this kind of shortcuts when you are writing these keywords over and over again. So as I told you before, like these conditions are evaluated to either true or false depending on the validity. And if expressions and elif expressions here, they use the result of these condition evaluated result of these conditions to determine whether the following code block will be executed or skipped. And if they are true, they are executed. If the condition is evaluated to be false, then they skip that inner code block. So indentation is very important in Python because that is the primary way of defining an inner code block here. So if you do your indentation in a wrong way, you are gonna get error. The interpreter will complain a lot. You will encounter this issue a lot, I guess, till you get used to it. Don't worry, it will happen eventually. But just be careful. I mean, if you are using some conditions, for example, if statements, while statements, for loops, these kind of control statements, definitely you are gonna have an inner code block which will be denoted with indentation. So that is something to watch out. So another common mistake is to use get confused about assignment operator and equality checking operator. So if we have single equal sign, that means we are assigning a value to a variable. In this case, we are getting a number from the user, converting it into a float, and we are assigning that floating point number to the variable y. But if we use two equal signs one after another, this is condition checking, and this expression will be evaluated as either true or false. So these two things, single equal sign and double equal sign, they are different. One is assignment, another one is condition checking. So there are some things we can easily perform with if statements. One of the inconvenient things about if statement is that the condition is checked just once by default. So the interpreter comes to this line, checks the condition, and if it is true, it enters that code block, inner code block, and it starts executing that code block and performs those operations line by line. So if we want our program to run indefinitely, such as in the case of like Legend of Zelda, whenever the character moves to the right, the game will take you back to this same screen. Now you will be stuck in a loop, but this kind of loop is not performed by default by an if statement, because it is executed only once, and either the inner code block is executed if the condition is true, or it will be skipped if it is false. But we can achieve the same result. I mean, we can achieve this stuck in a loop condition very easily with a while loop, because while loop is executed as long as the condition is right. What happens is that interpreter comes to this line, checks the condition. If it is true, it executes this inner code block. And after the execution of this inner code block, instead of going to the next line, it will recheck the condition again. If it is true, if it is found to be true, then this inner code block will be executed again. And after that, there will be another condition checking. So as long as this exit right condition is true, this inner code block will be repeated indefinitely. So that's one distinction between if loop and while loop. If conditions, if statements, and while loop. So as we talked, condition in a while loop evaluates to a boolean, and if the condition is true, all the steps inside the while code block will be executed, and this code block, this while loop, it will check the condition again after the first execution of the inner code block, and if it is true, it will repeat until the condition is false. This is basically what while loops in Python does. So this is an example, but I think we have already talked about this, so it is better to skip. So one of the things that we can use to iterate over some interval is also like for loops. So in Python we have if statements, while loops, as well as for loops, and we have two loops here. One is while loop and another for loop, which do exactly the same thing. So what happens is that both of these loops, they will print numbers from 0 to 4 and they will exit. See, both of these loops do the same thing. So this is the general structure of a for loop. We use the keyword for, then we put a variable name here and we define its range, and after that we use comma, and using indentation we define the inner code block here. So each time through the loop, variable takes a value which is defined in this part of the for loop. So first time variable starts at the smallest value, and each time it is executed it gets the previous value plus 1, so its value is increased by 1. So this is also a function, range function, and it will produce a set of numbers, an array, and we provide starting value, stopping value, as well as stepping value for this range. So default values are for the range function. For the start point is 0 and it takes the default step of 1, but we can also specify values for these variables here. So in this case, for example, in this example, the value of I starts from 7 and it goes up to 10, but 10 exclusive. So this the variable I takes values from takes values 7, 8 and 9. And here we have another example. In this case, the value of I starts from 5, it goes up to 11, but the increment is 2. So the values will be 5, 7 and 9. We have another keyword here, which is break, which is the statement. We use it to immediately exit from a loop. So whenever the interpreter encounters this line, it directly exits that loop and skips the remaining expression in the same code block. One important thing is that it exits only innermost loop. So if we have nested loops, which means like we have for and while loops inside each other, this kind of structure, whenever the interpreter encounters this break line, it will exit from the innermost loop here, while, and it will go to the outer loop and it will keep executing it till again it encounters a break line or the condition is executed to be false. So here we have an example. As I explained to you, what happens is that the EI takes the value of 5, its value per iteration is increased by 2 and it goes up to 11. So here what happens is that my sum is assigned a value of 0 here. So each time this inner code block is executed, we add the value of I to the my sum variable here. So whenever this sum reaches a value of 5, we say okay, we are done, exit from this for loop. Otherwise what happens is that the interpreter just goes to the next line, which is again another addition operation, but in this case it won't be executed. So this is one of the things you have to be careful, because after break line, if we come till this point, it means that we are gonna skip all these lines except of course print line. This line will never be executed. That is one of the things you have to be careful. So this is a comparison of for and while loops in Python. So for loops, we know the number of iterations because we are the ones who specify that number. But while loops, they are unbounded. so they can be repeated as many times as required. We can end both of these loops using break statement. It is valid for both for loops and while loops. For loops uses a counter, and that is how we specify the number of iterations. While loops, they don't need a counter, but we can specify, we can initialize a counter to keep track of the number of iterations, but it is not required. And typically, if we are using while loop, we don't do it. And if we need a counter, we switch to for loop. That is more convenient way of writing a code. So one of the distinctions is that we can rewrite a for loop using a while loop. This is perfectly fine because we can define an external counter to keep track of the number of iterations, but a while loop may not be rewritten using a for loop. From time to time this happens because of the infinitely repetitive nature of the while loops, which is not the case for loops. So this is end of the second class. At this point we can just play with the Python interpreter, and I can show you how this works so that you can get a better grasp of Python language. So let's reinitialize our interpreter. So we can start by playing with the range function. So we can just say, for example, range 5. So we can try this one. As you can see, it's evaluated more or less like a unity, so you don't get the values. It just says you that whenever you write this, it just says it is a range. It's a construct in Python, special construct that starts from 0 and it goes up to 5. Although we just specified 5, 0 is input as the starting point by default. So if you want to change it, we have to specify it. For example, if you want to start from 1, we have to specifically write 1. Then in that case, as you can see here, it is converted. The starting point is assigned to 1. And we can also specify the incrementing value, stepping value. For example, let's say 3. So as you can see, now we have 3 values. So let's use this in a for loop for I and in range. Okay, we can use this one. We have already defined from 1 to 5 with a step size of 3. Then we need to put a column here, and we can basically print this value just to see what's happening. As you can see here, the interpreter prints only values of 1 and 4 because the starting point is 1 and stepping value is 3, so 1, 4. The next value should be 7, but it is greater than 5, so it is not printed. If you want to print the 7 as well, we can just enter this 8. And whenever we run this loop, as you can see here, we have the value 7 there. So let's try to write this using a while loop. In this case, we have to define this counter externally, outside of while loop, basically. So we just say while I is less than 8. So what we do, we need to print that value first, print I. Then we need to update the value of I, because while loop doesn't do it. Although for loop increases it automatically, while loop doesn't increase the value of any variable. It just does the condition checking, and if the condition given here is correct, it keeps looping, it keeps running this code block, inner code block. If it is false, it just returns the control to the next code block. So we have to do the counter manipulation manually. So here I will just do it. So we want an increment value of 3. So we are increasing the value of I by 3 for each iteration. Then we say, okay, we are done. But here, okay, the initial starting point should be 1. I forgot that one because in the previous one we started with 1. So when we click 1, 4, 7. So yes, we can rewrite a for loop using a while loop. No issues there. So I guess you can understand the basics of Python language at this point. So I wanna finish at this point, and let's continue next week with our next lecture. Thanks for listening. See you next week.